We're good? Andy's on? Okay, perfect. So with this, I'm going to turn it over to our panelists. They're going to take and walk you through the ISSI discussion. Now, this is based on standards, not based on manufacturers, based on standards. What will the ISSI do? In this instance, a reminder, Andy Davis chairs the TIA TR8 committee. Roy McClellan has chaired the TR812, which is the subcommittee on TDMA2 slot. Jerry Drobka, 19 for subcommittee on wireline. And Mr. Jim Downs chairs the Project 25 user group committee. So with that, I'm going to turn it over to you guys. I think Roy looks like he's going to talk first.
Hey, I'm green. Next slide, please. Cool. And next slide, please. So I'm going to kick it off a little bit because since the purpose of the topic was the Inter RF Subsystem Interface, which is the ISSI, which is a wireline. Now, when it says wireline, it means it can be microwave fiber. It was even originally designed to work over 4-wire. It's not really a good way to do it, but with what's out there today, most likely microwave or fiber. It provides a standard interface between two systems for the purpose of coverage extension or coverage overlay, but allows two disparate systems to talk to each other. But to start out, there's a lot of stuff that goes on in the standards arena. There's a lot of bad press out there about P25, what it does, what it is. And so what we hope to do as part of this is to dispel that, but I'm going to kind of set the stage as we get into what some of the things the ISSI can do. I'm going to give you a few things to work on. Jerry's going to add to it. Andy may step in at any point and provide some clarity, or if we make a mistake in saying something, they'll provide some correction. Any of us would. But the standards provide, as you can see on this chart, a standard level of interoperable features and capability. Now, in the past, some people would say standards provide the lowest common denominator between two disparate things that you want to work together. But in the last 20 years, the advancement in the commonality and the adoption of each other's types of ways of implementing features that work on radios and on the infrastructure has really advanced what it is. So I don't like to call the P25 the lowest common denominator, but it is important to understand that there's a lot of things that P25 gets blamed for that don't have anything to do with the standards. The standards define the interfaces, and I gave kind of a little anecdote here, which is it's kind of like standing on the side of a freeway. And those that are in the electronics business, if you put a protocol analyzer on an IP line between two things, you can see all the messaging going back and forth. So when I've got the freeway, I see a lot of vehicles. I see trucks, cars, and variants. And I don't know where they're going, and I don't know where they came from. But each vehicle itself on that line knows where it's going, where it came from, what its mission is, what its capabilities are, and what content it's carrying. It's a little bit of an oversimplification because there's also programming that occurs on the endpoints that also says, just because this vehicle showed up in my parking lot, I don't know if I'm going to allow him in or not. In other words, I can see all this information about him, and he's not on my system, he's not an authorized user on my system, I'm just going to reject that. So it'll just show up in this world. It's kind of like graceful, it's like gracefully ignore stuff you don't understand. That's an underlying tenet and in the radio interfaces and in the wire interfaces. Something shows up that's a set of packet of information, you don't understand it, you gracefully ignore it, and in some cases, there's even some level of error correction built into it, like the ability to talk back and say, I don't know what you are. You're not allowed. You're rejected. So once vehicles arrive at the endpoint, it is up to the endpoint to decide what to do with it. And that's what I just kind of led into. So the standards don't define behavior. And one of my cohorts years ago used to say, just because I have an RJ45 jack and I've got the internet, that's a standard. Well, you know what? Even when you buy a new PC and you hook it up, it doesn't work. There's a lot of work that has to go on underneath to make that PC usable on the internet. So you have to make sure you have applications and things that you like and that the application is set up. You have to program who your ISP is in. There's a whole lot of work you got to do either with your machine or your network to whatever. So one of the things that you just kind of have an overall feel for that is that manufacturers continually test with each other to refine these standards and each other's handling of the protocol. And that means just because I have a standard that defined a packet went from point A to point B, You know, we all think differently. Ford, GM, Chrysler all think differently. They all have a car that does the same vehicle for you, but the computer inside the car makes the decisions differently. You can't mix the internal processor from a Chrysler to a Ford to a GM, or even between their vehicles sometimes, and have it make intelligent decisions for what that vehicle's, how it's going to react to braking, fuel usage, whatever. So we always are in the mode of testing. Ourselves, the company I'm with, is an infrastructure manufacturer. We don't build radios. We only build infrastructure. If the standard didn't work, we wouldn't be in business. Motorola and E.F. Johnson and Realm, and just there's a very large list of manufacturers. We all work continuously with each other to show that this stuff works, and that when we talk with each other on our equipment, we handle the protocol properly and make intelligent decisions with it so that the system gives to the user that same look and feel and operability that you'd like to see. Next chart, please. So in this testing, there's also some formal testing that occurs. There's the Department of Homeland Security Office of Interoperability and Compatibility, the DHSOIC. You've probably seen this a lot in the press. The P25 Compliance Assessment Program. That program provides a level of testing using NIST certified labs and third-party and manufacturers, and everybody agrees there's a certain set of minimum requirements that are tested there. Part of why the government does this is to make sure that if they're providing grant money to entities to go buy radios, that they're buying compatible radios. And they're continuing to expand this program. So if you go read the P25 specs, you'll see that many of the tests that the NISCAP program runs is using a subset of the tests that are already documented in Project 25, but it's not the full test, which is why, again, we continually work with each other. So now we have manufacturers working with each other continuously to make sure that all of our equipment works. Radios that we have in our lab, we are on a program with each of those manufacturers as they release upgrades, new code plugs, new things to do with the radio, that we can put those things in, and then we can test those features and functionalities with the equipment. All of us do the same thing. The government maintains their own lab that does some of their own work to support their own systems. So it requires a lot of testing outside of standards. It requires some testing within programs like the DHS P25 CAP program. One important thing to understand about the CAP program, because they've just got this thing kicked back off strongly again, and you can go back out to the, and I can't remember if I put the link in here, but if you just Google Project 25 Compliance Assessment Program, it will take you to their website. And you'll find documents on the website that are going to start migrating pretty quick. And what you'll find, like in our particular case, if you test the infrastructure with 3 radios, it might be a Realm, a Kenwood, and a Motorola, or it might be a Harris and a Realm and a ICOM. As long as 3 radios have been tested on that infrastructure and it passed these tests, then that equipment is qualified. Now, that doesn't mean I have to go test every variation of Motorola radio on it. Doesn't mean I have to have tested somebody else's radio. So you have to look out there, and you'll see that with Motorola, with some of their capabilities, they'll have very extensive list of radios tested. Some of the smaller guys will have a smaller list. But if you've passed that test, that air interface testing, you are P25 CAP certified, and you can buy equipment from those entities or beyond that, so that it all have some level of assurance that it works together. Also then, just on the manufacturing testing, to further emphasize that, the standards have a lot of options in it. And that's, again, one of the reasons we continue to test with each other, is you have to be able to work with these options. And if you go out and look, and sometimes some of these stories get dredged up that are many years old and get reformatted and rehashed in the media, but 99, this is my opinion, and from experience, 99.999% of the time when a P25 radio doesn't work right on somebody's network, it's a programming problem. It's not a standards problem. There's been some feature, code plug, or something that wasn't enabled that was set up the same so that that radio in a certain situation would react the same way as other radios that your users have. So that's really the first place to start. You've got to go check the program. NIPSTIC has recognized this. That's why they released and did a lot of work to come up with a thing called the PAM tool. I forget what it stands for, but it's a tool, a spreadsheet tool that allows you to put your fleet mapping and a lot of stuff in there, and it's attempt to try to get about 50% of the common language you need for programming radios so that you don't end up making the error of a mistake because you're kind of doing this piecemeal, this tool, and they're getting ready. They've asked the TIA to expand this, and there's going to be some work done on coming up with a further interface tool that takes us to another level so that you could have some tools that will try to make your radio programming more consistent. Same thing that Jim alluded to earlier, some of the big issues that have occurred is with this non-standard types of encryption. Sometimes people think I have encryption on this radio, but it wasn't a radio capable of AES. So you show up for an interoperability issue and it's like that radio can't be programmed with these keys. Next slide, please. So our first scenario kind of goes into, and from our discussions with Craig and the team here, you know, you've got some decisions to make on what type of interoperability you want. And our friend Andy Davis would emphasize that, you know, you've got to go think about what your user cases are. From the standard side, we're going to try to give you a few high-level elements here of what will occur in a few scenarios. So the first scenario here is a single system where you have mixed FDMA and TDMA on that system. I don't know how well it's shown up there. It looks pretty good here, but we have a blue bubble, and I've got some radios that are called Ts and some radios that are called Fs. Mixed users at a single site will typically force the FDMA mode for all users.
Roy, could you take just a minute and explain the difference between TDMA and FDMA? I don't know that we've covered that today.
Okay, yeah, you're right, I didn't think about
you.
it. There was a point where we're going to. So P25 today in FDMA is a single voice path in 12.5 kilohertz channel. And it has backwards compatibility to analog. In other words, if you follow all the games here, you build an FDMA radio, then it has analog capability in it. That analog capability goes from conventional to direct mode to, you know, several forms of trunking with using CTC-SS signaling, which you all know is kind of proprietary to every manufacturer. That was one of the things that led to P25, is when we're going to go into the digital world, we need a standardized signaling mechanism for trunking and operations that follows this, so everybody's doing it the same way. So when I'm talking, P25 phase 1 FDMA is a digital radio. It's taking the voice, digitizing it, and it's putting the voice out there in an RF pattern that sends that one voice from point A to point B. And because it's digital, we can do things with encryption and stuff that are a bit easier. If I do TDMA, it's slotted. And that made things a little more complex. And it turns out, and it's way too deep to go into here, but glad to take offline. When some of the other radios, like you saw, the early cellular systems were TDMA. And they started out with a 3-slot, then Nextel went to a 4-slot, or I've got the names wrong. They went from a 3-slot and then they turned it into a 6-slot. When I'm doing slotted communications, that means I'm taking the voice and chopping it up and I'm bursting it out with time. With the FDMA, it's just continuous. And with the TDMA, I have the ability to now take 2 guys or 3 guys or 4 and mix it up. Now, the reason we ended up with 2-slot on TDMA with this is that if we go to 2G cellular like GSM, which is what T-Mobile's original network was, there were 8 slots on a radio. And that was running in about a 200 kilohertz bandwidth. So we needed something that it had to fit in a 12.5 kilohertz bandwidth. There was the mandate to go from 25 to 12.5 and get more efficient. So doing 2 slots is what we do, but we had to do some fancy things in there, and technically it took a while to hone this out. The other thing that came in there was we had to come up with a different variation of the vocoder. So when you talk into an FDMA radio, I've got a vocoder that's digitizing the voice, and it's putting it into packets that you can understand from point A to point B. When we went to TDMA, I've got essentially half the bandwidth to do the same thing for the voice. The good news is the company that developed the vocoder, DVSI, came up with a way that they actually came up with new algorithms that greatly improved the vocoder for half rate, to where their half rate vocoder quality was better than the original FDMA vocoder in P25 phase 1. Then that led to an improvement in the P25 phase 1 vocoder. But I'm slotting it, so when I go look, if I could chop this and look at it in the air, where if I'm talking to you now and you just see it continuous, you would actually be looking at me having that burst, and then at the end, you're reassembling it and putting it back into the pieces. And because of the slotted nature, there's some capabilities that we're able to do that will eventually make some possible improvements. There's no agreement on this yet, but power control, on the radios today, if there's some power control, it's rudimentary, and you have the near-far effect on the sites where you can overpower another user, or when you're close to the site with TDMA, the ability to possibly ratchet the power, the transmit level down, so you get battery conservation. And then the other thing that's a hot item, if we can get there, is in TDMA with a slotted structure. Once you go to a slotted structure, I have two-way control plane communication, which I don't have in FDMA today. In other words, in FDMA, I have a little bit of control information I can send out, but I can't, the guy who's talking, I cannot communicate to him. And if you've ever dealt with a screaming controller or a locked up radio, stuck on transmit, it's causing a lot of issues. In TDMA, a radio theoretically stuck on transmit would allow me to actually get some information back to it and shut it down. And that brings in a possible future thing that says if I have a talker and he's at a lower priority, I could actually preempt that guy and get him off the system and let him know that I'm doing that. So I kind of danced around that a little bit, and what we'll do is take some questions later, but just again, it's a bursty thing versus what FDMA is. The FDMA radio is really a little bit more like FM. I talk and it continues to transmit until I let go of the button. With the TDMA, I'm talking, but I'm talking in burst. That allows a guy standing next to me to mix his intermix his burst with mine, and I've got two bursts going up and down for each radio that's talking.
So Roy, if we've got an FDMA radio like your chart shows, in a little bit it's going to show talking to a TDMA, that it would take a full channel instead of a talk path for the FDMA and TDMA to communicate on the same talk group.
Yes.
Right?
So typically what's going to happen then, if you think about that, where I had the ability to put two guys into the same lane on the freeway and mix them together, and now one guy shows up that needs the whole lane by himself because it's a legacy radio that's P25. I've got to take the two-slot radio, it will ratchet itself down based upon control information from the system, and it will start to operate in an FDMA mode. So it's an important thing to think of, because when you look at what you're going to do and the models that are used to back up your grade of service, if I have a 3 radio channel system with 6 talk paths, and then I have an FDMA interop event that occurs in that system, I now went to 4 talk paths on the 2 remaining TDMA channels, and 1 talk path turned into an FDMA channel. I now just went from 6 to 5 channels. As Craig mentioned earlier in his discussion, more users with the same number of channels push the grade of service down, so your call holding and waiting times go up. And if I add channels, because I'm adding users, then I can keep that grade of service constant. But if I build a system and I do too much FDMA interop on the TDMA system, and I had 3 channels go to FDMA interop, you went from 6 talk paths to 3. These are considerations to think about when you do this. There's a capacity impact, and I just described some of the other elements. There is some product capability stuff you have to look into here. The standards provide a lot of leeway of how you implement this, but there's business decisions that each manufacturer makes as to, you can have features that nobody buys, so it doesn't make sense to put too much money into those features. So you need to make sure you understand the product that you're dealing with and who it came from and what they're supporting, so that you can get through some of these detail items. There is the capability in this scenario that's on this chart. As you see, I have a single system, but I have 2 sites. So one site's got TDMA talkers on it, and the other site's got FDMA talkers on it, and those are in the same interop talk group. So now the TDMA, the one site on the right there that has the Fs, that's taken one channel, turned it into an FDMA channel from the 2-path TDMA channel, and when it connects to that other site, if you don't have, some systems have the ability where if I'm talking on a site, I don't have to drag another site down, in other words, channel saving. I don't occupy resources on that site just because there's traffic on this site. But if those TDMA guys and FDMA guys are mixed, those TDMA guys, for the way the standard would work, is they would go down and drop to an FDMA mode. If the FDMA guys have TDMA capability, the system's going to try to put them all into a TDMA call, unless something prevents that.
So if we've got 10 radios and only one of them's in FDMA, everybody has to talk in FDMA to have interoperability, even
Yes.
though the other 9
Yeah,
are
Jerry has
TDMA.
something he wants to add.
Well, if I have, the final bullet talks about rate conversion. So if the system has rate conversion, which means it can turn half rate into full rate or full rate into half rate as part of its software capability, I could have TDMA a site that's all TDMA radios talking to an FDMA site or with FDMA radios, and I could rate convert. And then I'm not using double the resources at the TDMA site. But that's a manufacturer
And that's
capability.
across sites, right?
Yeah, that's
So it would be
across
2 different sites. Okay.
Yeah, but that's a manufacturer capability. It's not part of the standard rate conversion, but it's something that is being done.
Yeah.
Okay.
The standard enables this type of capability, and this gets into how a manufacturer uses it, because the standard defines the protocols and a lot of messaging. That messaging allows you to do some things like this. Not every manufacturer may choose to do rate conversion. So that's the ability to have, it's kind of like having a French guy on one side of the room and a US guy on the other side of the room, and they're able to talk to each other because there's a translator in the middle. There are other impacts of this type of stuff, and the reason this is here is it's also going to lead into some of the other charts when we talk about ISSI and linking 2 systems together. These impacts that occur in terms of capacity and choosing the most common mode of operation are a big factor then when you're linking, say, your regional system to the statewide network or vice versa. You want to go to the next chart, please? So the next scenario is a multi-system, multi-site, mixed user scenario. So what you can see here is there's a red system and a blue system, system A, system B. And what you have is radios on each side of that system. If you think about what we just gave you in that previous chart, kind of envision that in the middle of these. In this scenario now, we're starting to bring in the ISSI. And Jerry's going to bring in some more information about this after I kind of get through this. The endpoints obviously have to be programmed to understand that I've got an ISSI there. There's a lot of programming associated with ISSI. And there's a lot of programming that goes into your radios. To give you an example, there's an ISSI between DFW Airport and the City of Dallas system. And the City of Dallas system then connects to 7 sites in the 7 counties that surround DFW Airport. It's a big interop system because if there were a crash and you get into the DFW Metroplex area, you have 30-something agencies and entities involved, and an airplane crash unfortunately brings in a lot of resources from a lot of agencies. So there's well over 30 mutual aid talk groups programmed into this system. So everybody that's authorized to be on that system has all of this stuff coded into their radios. It's a lot of work that's required. The fleet mapping and all the management of all that is a huge task, far beyond the technical aspects. And that's a thing to kind of keep in mind. So endpoints have to understand the capabilities of the users and the sites. And Jerry's going to talk about the manual and automatic roaming aspects because it gets into, I can go across this ISSI and I can turn a knob on the radio and choose. Once I know I want to be, like if I'm on a regional VHF and I've got a multiband radio and I switch it to go to the state network, I can just run that switch and be part of that network. My home network only knows I'm gone, but there's no talk back to your home network. So if I turn the switch and do that, then that's one way to roam into the other system. If I put the ISSI in there, I have the ability that I can roam into the other network and have a talk path that goes back to my talk group and my console operators in the other system. There's capacity impacts that have to be looked at in that. So in addition, as I say here, There's some user and system discovery required on registration. The user has to be authorized to work on both sides of the boundary. There are ways where ISSI can assist in that, and the ISSI can also be used to not assist in that. It can do nothing more than just talk, give you a voice path between the two systems. These are a lot of decisions, as I understand it, Craig, that these committees and all of your users have to make. So you, again, have to look at your capacity impacts. It's kind of the old story of if the posse comes rolling across the boundary into my system and you haven't planned for that, and your dispatchers don't know that, and they've got talk groups that don't include the dispatchers, all you know is your native users would see it's taking longer to get access. In other words, I push the button and the time before I get the channel grant beep has increased noticeably because I've got other users who are now doing a lot of PTTing on the system, and they came across the boundary. So there's a lot of planning and service level agreements and agreements that have to be put in. How are you operationally going to do this? And sometimes it requires different entities who operate differently, that you actually have to make sure that your operations expectations are coordinated so that a guy from this system, that if they were native in each system, they get different types of performance expectation. They now have to be matched to where they understand that if I go across this boundary, I may be working more in this guy's operational scenarios than where I came from. If supported again, vocoder rate conversion, if you look at this chart, can convert between system A and B. In other words, I could have system A could be all FDMA, system B could be all TDMA. The rate conversion capability across the ISSI gives you the ability to connect these two entities together, and it doesn't affect the capacity on each side of the network. And I'll let Jerry throw in some more stuff as he gets to his part here. We have to be careful about ISSI. People sometimes think of it as a box. It may be a box. We tend to call it a gateway, or we call it functionality. And again, that's manufacturer dependent as to whether it's a separate item that does it, or whether it's capability built in with there and it's a jack to plug something into. But don't get stuck by it's a box or it's a gateway or a functionality, but it is a functionality that's built into these systems and is supported different ways in terms of how you get it from that manufacturer. So that's why I said at a site or system, this rate conversion is going to occur somewhere within that core interface. And it's important to understand that once I rate convert, if I'm doing encryption, then my rate conversion needs to occur in a secure place because it's two different vocoders. I got a guy speaking French and a guy speaking American. They're both encrypted. To get them to talk to each other, I've got to de-encrypt someplace, get the language conversion done, re-encrypt, and send it on its way. So that's something all the manufacturers are well aware of and will provide guidance that says, but you need that. Most entities would say, I need that process to occur in a secure place where I know that I can protect that. Because once it goes in the clear, then it's a place where somebody could sniff it. And then if there's no vocoder rate conversion in this scenario, it's the same thing as we said in the single site scenario. People that are FDMA only would end up causing a call with TDMA users to ratchet down to the FDMA mode. One of the things we didn't have time to get into here, just brief, but if you think of this little diagram here, you can look at this as two systems next to each other. But you can also look at it as two systems that overlay each other. So if I have a city system that's underneath the state umbrella, city system's VHF only, state umbrella is TDMA, you have the ability to have mutual aid talk groups. You will be taking up a voice path on each system. And if it's an FDMA call on the city system on the VHF, and I'm connecting to the TDMA system, it's going to cause the loss of some capacity on the TDMA system.
So if we could just take that for just a minute, Roy, that particular topic. If we have multiple FDMA city systems within a single county, and we have automatic roaming, the FDMA users from the city, as they travel out, bringing their operational talk group with them, could conceivably busy out the TDMA system because of let's just say there's five cities have their own standalone FDMA trunk system and they're ISSI'd into this countywide system. If they go on the same tower site for a funeral or for some other event that might be important for them to be there, and they're listening in on their traffic, they could conceivably busy out the TDMA system because they're in FDMA mode, and they will actually begin to busy out themselves.
Yes and no. I mean, fundamentally, if you think of, you would need multiple things to occur at the same time.
Okay.
Okay? In other words, you would need multiple entities to start interoperating to the state system, where you have, say, 3 mutual aid talk groups that are each using a channel in their system, which are now pulling and interlinked to the state system. And it doesn't matter whether it's manual or automatic roaming. If you have the ISSI and the voice paths can be there, if I put 3 full rate voice paths tied to the TDMA system where I had half rate voice paths, and I make the 3 radio channels, which had 2 paths each on the TDMA system, each drop down to FDMA, then at that point, yes. And obviously, they'd have to be talking a lot, okay? Even under the worst scenario, when you talk about the public safety call model is like 4-point-something seconds, depending on who you talk to. And then you get into EMS guys run about an average call holding time of 25 to 35 seconds. They tend to talk longer and more. So you have to look at what the scenario is, but this gets back to what I said before. All the entities participating have to sit down and talk about operationally, how are we going to do this so that the users on the system just don't see that call holding times, or, in most of these systems, there's a default of 30 to 45 seconds in the radio that says if I PTT'd and within 30 seconds the system can't grant me a channel, it's going to reject the user and say I couldn't get you a channel. So then he's got to PTT again. So don't want to get too far into complexity. We're hoping this leads to more questions. And most importantly, as Andy would tell you, what are your scenarios that you would envision, how you would use these systems if they were linked? Who's going to be informed? How do your system dispatchers alert people that, are we going to go and tell everybody with some sort of broadcast call, there's other operations going on? We may experience longer times. And there's also, depending on the manufacturer, there's the way to configure channels to where you could just say, I could set up a channel to where it's TDMA only, and that channel's never going to drop out of your system, and the call holding time problem would go to the guys doing the interoperability issue. And Jerry, I'm sorry, you had something you wanted to add before we get too far from it.
I think you touched on it. I was going to talk about vocoder mode negotiation.
Okay. Well, it's time to, I think, unless there's a question, we could move on to your deal. Does that sound good?
So when we added TDMA to the ISSI, we had to add the half-rate vocoder, and we also added what's called vocoder mode negotiation. So the 2 systems are going to tell each other which vocoder modes they can support for each call before the call starts. So there's a negotiation that goes on where they decide if they have a common mode for the call. And the home for the group is the one that chooses the mode that's going to be used. So in most cases, you'll find a common mode, but there is the possibility that at that point in time there isn't one, and so the call wouldn't be started. And then the home has to decide what it's going to do, if it's going to let the call go to any other sites not associated with the ISSI, or if it's not going to allow the call to happen. And so the mode that you want to use is going to be based on the subscribers that are in that group that are active and what their capabilities are, and then the capabilities of the sites that they're located at. And then whether the RFSS can do the rate conversion will play into what modes you can support. So that's a new capability that was added when we added support for TDMA systems.
And let me add, there's error messaging that's part excuse me, part of the protocol. So if the system can't negotiate that, there's a message that will go back to the system trying to initiate it, letting that system know that this couldn't be done. So it's not something that's just blind. That obviously is going to come up to, you know, the level of monitoring you have into the system and who's available and watching it on a daily basis. But the ability to go in and see that the interconnection was getting rejected, there's actually reason codes for those rejections.
And so prior to implementing the ISSI, you should understand the use cases and, you know, plan for what modes are going to happen so that you can pretty much rule this out.
Andy, do you want to add anything? Did we lose Andy? Andy,
Can you hear me now?
Yes,
Speak.
please. Go ahead, Andy.
Okay, thank you.
Thank you.
So just a couple of points. I mean, Roy has pointed out that the standard allows different ways for a single system to handle a call at two or more different sites that involves both TDMA and FDMA users. Some sites could be FDMA, some sites could be TDMA, the whole thing could be FDMA, depending on the specific implementation of whoever infrastructure you're using and whoever's radio you're using. I think that extends to the ISSI, as Jerry's explained. So I just want to emphasize one more point. The standards enable interoperability of a variety of features, whether it's the air interface standard or the ISSI wireline interface standard. But the standards themselves don't require manufacturers to implement any particular feature or set of features. The manufacturers independently determine what features covered by the standard do I want to implement based on the market segment that I target or that I serve. So just want to emphasize, it's very important as you understand what the standard enables to take that to a lower level of detail. What do your particular manufacturers of interest support from the standard? That's really all I wanted to add. Thank you.
Thanks, Andy. Okay. Next slide.
Next slide.
Next slide.
So as part of the ISSI, we have roaming, where a subscriber moves from the coverage area of one system to the coverage area of another. And there's two kind of ways that this is handled. The first one is what we call manual roaming, and that's when the user of the subscriber turns their knob and they activate a personality that makes them a home user of the new system that they've roamed into. So now they look just like a home user to that system, and their ID that they've got in this personality will have to have been configured in that system so it knows it could show up as a home user. And so then the functionality that you get when this happens and is going to be based on what that subscriber can do and what the home system can provide. And so the other type of roaming is called automatic roaming. And that's when the subscriber moves into the other system's coverage, and it just automatically registers with that system, and it's keeping its ID from its home system that it came from. So to this what I would call the visited system, it looks like what you might call a foreign user. So it's going to see that registration, and then it's going to send a message on the ISSI back to its home system to tell it, hey, that this unit of yours is located here in my coverage. And then that system can provide a a profile back to the new, the visited system that can give it some information about what that subscriber is allowed to do, that sort of thing. So now you've got what's sometimes called a foreign unit on your system. And so the its capabilities are going to be based on how the visited system treats it and what functionality has been implemented across the ISSI. Like if its current home system could try to send a message to it, and you have to understand if that's supported in the configuration. And then in order to do automatic roaming, the radio has to support what are called extended IDs. It's a longer ID that has to be used when you do your registration, so you can get the WACN and the system that the radio's from. And then when the radio roams over, you have the FDMA, TDMA decision when it shows up at a site in the visited system. You know, if it's an FDMA only radio, then that's what that site's going to have to provide if it's going to be active in a call at that site. And if it's a TDMA capable, then it could partake in TDMA calls at that site.
Barry, let me add a note. The reason we threw this full P25 addressing issue in there is there's a lot of legacy P25 radios out there. And that may be particularly true when you have some of the regional systems that link into this. For it to be able to do any of the automated mechanisms is that not all radios out there, depending on their age and capability of the radio in terms of what it can be upgraded to do, may support the full addressing. So that's why we put that one particular point in there, is you have to know that it may be a P25 phase 1 full rate vocoder only radio, but it also has to be a radio that could be upgraded to do what's called full addressing. The standard allows to get you a little bit of efficiency in the number of bits that you can do a abbreviated addressing within your own system. But when you mix systems and you do the things we've talked about where you want to connect disparate systems, you need to be using full addressing for the ISSI automated capability to work.
So, Roy, you just really added a layer of integrated complexities to not only the ISSI elements, but now the addressing and then legacy radio equipment that may have to have significant upgrading and programming to be able to carry out the ISSI functionality.
Automatic
Is that
roaming.
fair? The automatic roaming
Just
element?
the automatic roaming element.
Yeah.
Okay. So I guess it's safe to say at this point that there's a lot of integrated complexities to go along with the diagrams that we saw. It's not like putting a patch up and
Right.
patching two things together.
It's a bit more elegant and efficient than a patch, but along with that improved capability there's a lot more work that has to be done to be able to do it, and then you've got to also know what all your equipment is capable of for doing that.
Well, before we go to the next slide, I'd like to give Jim Downs an opportunity. If there's anything, Jim, you'd like to add based on the work that FPIC, and I know you've held a couple different ISSI meetings, and would someone explain what WACN is for the crowd while Jimmy's turning on his mic?
It's wide area communications network. It's the overarching ID, and then there's also a system ID. So, I was trying to think of...
A WACN can have multiple systems.
Right.
And then there's RFSSs within, but that doesn't go over the air within the system.
Andy, do you want to add anything about WACN and RFSS and system ID that we're not hitting very well here? Not there?
He said no. Okay.
We've lost
Jimmy?
Andy. Back to you, Jim.
Yeah, basically just a couple things that has already been mentioned. Just to go back, the most recent comment about capabilities in automatic roaming, and a lot of people think automatic roaming is based on some of our working sessions we've had within the EPIC. A lot of users, automatic roaming. Everybody wants automatic roaming. It's, easy. My users don't have to worry about switching the knob. And what you just heard here is a little bit more complicated than that. But one of the things I want to kind of emphasize to what both Roy and Jerry mentioned was, there's P25 compliant systems, and then there's P25 compliant systems. And without getting into the compliance issue, that's not my point. My point is, when did you implement your system? How long ago was that system implemented? And that system may have been implemented with certain features and functions that were totally compliant with the standards at the time. As the standards mature, other features and functions get added, other features and functions get standardized. And going back to the automatic roaming, if your system has been and I don't want to call it a legacy system because that has a different connotation to it, but if you have an older system, some of the programming and things, I think that Roy and Jerry, and they can certainly correct me if I misstate this, not only is programming, it's not just a matter of, well, maybe I have to update my programming or I have to reprogram my radio. Depending on how old that radio is and how long ago it was purchased, it may not be a programming issue. It may be a firmware issue. You may have to replace that radio in order for you to provide that capability of automatic roaming into a newer system or a different system. So again, it goes back to what you've heard already. When you're starting to do some of this, it's a very complex thing, and I wish there was a simple way to say, yeah, you got X, Y, Z, and I don't know that we'll ever get to just have a simple case of X, Y, Z. We hope to have a simpler case of X, Y, Z as we move forward, but I think there's a lot of complexities there. I think use cases and identifying just, if I'm going to tie a system A to system B, regardless of whether it's mixed TDMA or FDMA, if I'm just tying system A and system B together, you got to really sit down and do some kind of use cases and what kind of features actually does system A have that system B needs or that you want to transport across that ISSI. And there's a lot of complexities to that that we're not going to be able to just, get into that today because it's, like I said, there's a lot of complexities to it.
Well, the reason I asked that question, Jim, was that I know at a couple of the different meetings that you and I have attended, one of the things that came up also was software compatibility, that and it can even be within the same vendor community, but if my software gets misaligned, at least that's what I took away from Denver, is that it was easy from the user community to not be ready to pick up to shoulder the cost of that software upgrade yet. I don't have any other value added that necessarily makes it in my best interest to do that. But now the other side of the ISSI did, and there have been, at least that's what I heard or took away from it, is that there were elements that may have changed the way they interact and how how appropriately they interact until the older version of software then somehow gets upgraded at whatever time.
Or replaced.
Yeah. So, and I only bring that up because these are largely software-driven topics that we're talking about as opposed to hardware pieces. And so the software upgrades are the challenge as we look at interoperability going forward. The other piece I'd like to bring up here is, and we've really been silent to in our spreadsheet so far, is that the distance between these two in Jerry's drawing, if you could pull that up again, Sean, it doesn't have a slide number on it, but any of them have got the ISSI and line on it with the scenarios between system A and system B. So the last slide.
You want the one that says roaming automatic versus manual, is that right?
Yeah.
Yeah.
Either one, probably.
Andy wants to speak? Oh, okay. Would you let Andy speak while you pull that slide up?
Yeah, well, can you hear me? Okay, here we go. So while you're doing that, again, the ISSI standard has a lot of capabilities. The important thing is to find common capabilities of both endpoints. That's going to be what you can interoperate on. Software versions also make a difference. You know, which software version supports which standard capabilities. When it comes to manual and automatic roaming, that's a very common one. The ISSI can support audio connections with or without automatic roaming. That's something to keep in mind. The automatic roaming is enhanced by the ISSI in that it can coordinate authorizations. So my radio has moved into your coverage area. Do you accept my radio? Do I allow you to accept my radio? Those kind of things. So just wanted to emphasize that the ISSI is really a protocol. And what features in that protocol have been implemented by which version of software of both endpoints, both the systems and the radios, is very important to consider. That's going to be what makes the final determination of what features can you interoperate with.
Thanks, Andy. Can we get the slide up? Thank you. So on this particular slide, the black arrows and the black lines going back and forth between the systems, part of that is a backhaul. There is a form of communication that is going on, wireline, microwave, fiber optic, something between those 2 points, right?
Yep.
Okay. Who pays for that?
You do.
Someone does.
Someone has to
does.
pay for it.
Yeah,
That's-
so when we talk about those, will a single microwave path, I mean, how much capacity are we talking about? Is it how many talk groups you bring with you? Is that what drives it?
Yeah, but keep in mind today, you can't find a piece of, you used to be able to buy a microwave, something that mounted on the tower, say at, 15 gigahertz, 18 gigahertz, did 4 T1s. Mm-hmm. And then you could put IP, and then the manufacturers started selling those with IP, right? Nobody sells anything of that capacity anymore. You can buy the one that's the equivalent of an OC3 for the same price. So when you're talking about the messaging and stuff that occurs in P25, where you're looking at essentially something that's around 9 kilobits per second within this 12.5 kilohertz channel, there's just not a whole lot of bits there. So the needs of this versus what you can obtain for a path today is whatever you have for backhaul is going to be, this is going to be pretty inconsequential. It's going to be a bigger issue of just planning how you get the traffic into it and out of it and where it resides in the network.
Okay. Could I run a system on microwave backhaul and then still use a fiber optic connection between the two systems to connect them to controller to controller?
Well, are you talking about 2 parallel paths? Or are you talking
No,
about?
I'm talking about not using the microwave backhaul for the ISSI elements at all.
It's an IP-based interface. It's using what's called session initiation protocol as a foundation, and that's a standard internet telephony protocol. So as long as you've got an internet connection and you've got the ability to route that traffic where you want it to go, then you've got what you need to do it. Okay. It's really, in today's world, when we first, like I said earlier, when we first started planning this, we still were dealing with a lot of sites that were using 4-wire copper to some sites. And so they wanted the ability, And between some of the systems, you know, even one of the systems we did in recent years still had some 4-wire between a couple of the interop centers. So it's not something that this protocol was really optimized for. In theory, capability-wise, it could have done it. But, you know, you're talking about, you know, something that would run on that today would be fractional T1 as an equivalent. I'm not aware of any IP thing equivalent to the old fractional T1. But again, it's more of a routing and programming and how your network configuration is than it is it's going to chew up a bunch of capacity on the network. You could have a massive number of simultaneous ISSI connections. It's just not going to strain anything that's out there today, if that helps. By the way, we should have said earlier, and I'm going to get into it in a minute, but you know, we're here as a resource, and we're going to talk about, you know, how the TIA can be a resource. But with somebody like Craig here, you know, I'm not an expert on the system addressing. It's not something that I've personally worked with, so that's why I'm not able to just sit here and talk on it. But if there's something that leads into further questions on any of this after you walk out of here, that's part of the purpose of this meeting, is get that information to Craig in his office, and they'll be happy to act as a liaison for you into the process so that we can get questions. And we'll either be able to answer those questions for you. We'll get a little little ad hoc group up amongst us that wish to participate from the standard side, and we'll get back to you on any questions you would have. You want to move on now?
Yep. Yes. Jerry, I think I interrupted you.
Yeah,
No problem.
go ahead.
I think the next slide.
Yeah. There you go.
So these are some of the other complexities that you're going to want to consider and talk about. Encryption. You know, if you've got encryption going across the ISSI, you need to have the keys associated with it at both ends. Packet data. If you need packet data, how are you going to get that between the two RFSSs? And then there's supplementary services, which are features like remote unit monitoring or radio inhibit and uninhibit. You'll want to walk through your use cases for that and how you would want it to work. You know, if you've got your home system needing to be able to disable a roaming unit or not. And then the console interaction. The ISSI is also the CSSI. There's some specific definitions for consoles. So you could have a console subsystem that adheres to the P25 CSSI, and that could connect into your system as well. So you want to think about whether you want that and how the consoles are going to interact with your system.
So let's talk a second. So the sheriff had mentioned that he had a particular brand of radios that they were using on their for console. And then would this CSSI allow that interface? You know, from a CSSI perspective, or you're talking about two consoles that are tied to the zone controllers?
Oh, it's a console subsystem that's connected into the network. It's not an air interface.
It doesn't go out over the air. It stays
No.
within the system.
Yeah.
Okay. So we could have console-to-console communication without going out over the wireless.
Well,
With CSSI.
not exactly. It's so you can buy your consoles from another vendor and connect them to your system and use them. So those consoles can talk to radios and do everything that the other vendors' consoles do.
Craig, from a user perspective, basically, and again, you know, the real experts are at your right, but the CSSI is basically, if you look at the early stages of P25 and what we referred to as the RFSS, the standards define the RFSS as being basically a bubble that was non-standard. I won't say non-standard connections within that bubble, meaning that one manufacturer had a console and a trunking controller, et cetera, and that was inside the bubble. What the CSSI did was it was called a phase 2 interface, was basically it gave the ability for you to go out and procure on a competitive basis a different vendor that could interface into that existing infrastructure. So you basically have console manufacturers from other manufacturers being able to operate in that RFSS or multiple RFSs, however your infrastructure was designed. That's really the real purpose of the CSSI initially. And then, as Jerry said, the ISSI and the CSSI, there's a lot of subsets of the ISSI that are applicable to the CSSI. So they're somewhat married in many cases as
Yeah, we don't have
testing.
a separate.
The reason I bring it up is that when you talk with regard to the 911 centers, there's a lot of concern with, hey, how do we interoperate? Do we still need to have point-to-point? Do we still need other voice paths to travel through? And that was the reason I was trying to tease out more of this conversation, is that there apparently is within this model through CSSI another opportunity that didn't exist with conventional radio systems. So it is
Hey,
from
Craig.
dispatch center to dispatch. That Andy? Yes, sir.
Yeah, just one more thing to add to emphasize what Jim was explaining and what Jerry touched on. It's really one protocol that serves connection between RF subsystems or an RF subsystem with a console-only subsystem. But inside the RF subsystem, you can still have consoles. So the CSSI enables one console manufacturer to interface with the RF infrastructure of another manufacturer. That RF infrastructure manufacturer may have their own consoles. So the CSSI is really only required when you're mixing manufacturers.
Okay.
And I would add to it, today we give them two separate names, ISSI and CSSI, which CSSI is Console Subsystem Interface. And in the early days, we actually had a separate document for the CSSI, but it's actually all, it's all in one document today. It's ISSI because CSSI added some functionality on top of the ISSI, for example, the ability to mute an adjacent, so you don't want to have the feedback loops on the console. So when the guy's talking, and you need to know who's talking so that you can mute automatically the microphone on the adjacent console so you don't get big feedback loops. I think is that a good example, Jerry, of one of the capabilities in there? Is it's console ID or position ID is one of the elements of it so that you can manage the console operation smoothly.
And there's different levels of console transmit priorities, so you can have some higher level priority consoles that could take over a transmission of a lower priority console. What else?
And I'll jump in. I think Zetron was mentioned. Zetron's been very active in this arena, so they're one of the first ones that got out there and demonstrated CSSI functionality. They tend to call it that because they are just the console, but it is, again, the ISSI is what has the entire protocol for setting up and tearing down and managing calls, the voice paths, and the CSSI then brings the specific functionality for consoles, and that importance can increase because most entities have a emergency center, so that if your main center is taken out for some reason, flood or power generation failure or whatever, that there's a backup emergency office where all the dispatchers can move and continue operations from that backup area. And that may be a case where it's just what you would call a CSSI to link that center in, but again, it would still be ISSI and CSSI.
Well, that's a very important topic as we talk about things going on in Iowa right now because there's been, for a couple of years now, there's been a lot of talk about consolidation and different ways for systems to, or for dispatch centers to carry out their activities. And so it's a very emotional topic, and it has a lot of sticky wickets in it. Not that we want to get into it here, but it sounds like that may be topic for another conversation with the potentiality of CSSI and what it might bring in something like that.
And just to add to what Jerry said, on the supplementary service, we particularly put down remote unit monitoring, and this is a good example of, when you have two systems you're going to connect together and how different entities work. Well, entity A may not allow remote unit monitoring. In other words, they say we don't want the ability to silently link into a guy's radio and listen to what's going on. We don't allow it for whatever reason, but another agency does. So you have to get together and decide on these types of things. Now, another feature that is commonly used by everybody is, in addition to what Jerry said, is emergency alarm. In fact, emergency alarm brought out one of the first issues we had to go clarify. Turns out two of the manufacturers originally treated emergency alarm and the teardown of it differently. And so it happened on one of the first ISSIs that was put up. And so one entity would try to tear the emergency alarm down, but one entity only allows emergency alarm to be torn down by the guy at the console operations center, and another entity allowed emergency alarm to be torn down by the radio user. And there's philosophies that you get into with people, and this is where you talk about manufacturer capability. So what happened is that emergency alarm was asserted over the ISSI. That's where an officer, somebody pushed the red button, the red triangle button on the radio, and you get the beep that goes through the system, and that was echoed across the ISSI. But now you got into a problem is that one entity would try to tear it down, and then the other guy would PTT his radio again because his system didn't tear it down. Every time he PTT'd, the system remembered that he had pushed the emergency alarm button. In other words, today, if you push the emergency alarm button on the radio, it will tend to, every time that user PTTs, he stays in emergency. So if you're on the other end of the radio and you've experienced this, you'll see the call come through to your radio. You see that this user ID is in emergency. You talk back, you're not in emergency, so that ID goes back as not an emergency. Every time that guy talks until he disables it on his radio, in other words, the guy who had the emergency is the guy who has to disable it. Well, one of the manufacturers felt like that is something that we're not going to just leave in control of that user. Maybe the radio's been compromised. So it required the console operator who had technical position capability on the system to tear it down. So every time the other system talked to the other system, it kept so what was happening is there's this stupid loop that the emergency alarm would never go away. So that ended up causing us to get together very quickly and put some clarity into the specs so that we clarified that under emergency alarm, we have to account for these types of actions. You have to account for, in the standards arena, we all work very closely. We can't create standards that obviate what another manufacturer does. In other words, you can't just go tell somebody you've got 2 million radios out there and 85 systems and you've just got to go change them all because we made it. So we try to create the standards such to where they can account for these things and give you programming options but that does throw the decision into you as users as to how you're going to do this. So things like emergency alarm are that was like one of the first things out of supplementary services that was like a table stakes item for putting in ISSI, but things like remote unit monitoring may be something that do your radios even support it? It's a code plug in most radios, so do you even have the license to use it? And then is it something that your agency allows? So that gets into what are your operational scenarios? What are your user scenarios? And everybody's got to sit down and do a lot of talking to make sure that you can align between your departments, that we all agree on this common mode of operations. Kind of leads into maybe creating some sort of a ConOps document that everybody agrees to. I guess what we might do is go on to the last chart before we get too far from it.
Can I just add something to what you were just saying there? Basically, go back to that emergency call activity. One of the things that I think the app. I don't want this to sound like an infomercial for the EPIC, but maybe it is. There's a lot of users involved in that. And some of those things like that issue that Roy just identified, a lot of the EPIC sponsored a working session. That problem that Roy mentioned was identified. Actually, I think that was the first implementation of the ISSI, and to complement the manufacturing community, the EPIC worked with that, sent a letter to Jerry, actually, at TR 819, asking them to look into that problem, which they had already started to do, I might add. But manufacturers work very quickly and very closely in identifying a fix for that problem, without having to go back out and, like Roy mentioned, you can't go back out and tell somebody they're doing it wrong and somebody else they're doing it right. But one of the things that we sponsored that Craig mentioned earlier, a working group in Denver last year among the user community. There's a lot of implementations going on today with multiple manufacturers and all the manufacturers, to include the console manufacturers, bringing everybody together and try to resolve, what have you done, what's good, what's bad, what's ugly, and those kinds of things. But the one theme that I want to mention here is that in every case, the people that were implementing ISSI among using different manufacturers, all the manufacturers worked very well together. Once they brought people together and identified the problems, they were very quick to address the problems, to move forward. What came out of that was a number of things that we want to continue to address that Craig has already mentioned, software revisions or different versions of the infrastructure, things like that, and get a better feel for that. But also one of the things that came out of that, which I just want to put a plug in for the EPIC and the NICSWIC for that matter, is to identify some basic features that we could call minimum requirements as we move forward. Not to go back and say, go fix this and spend millions of dollars, but to move forward and say, here's some basic features that we think as you move forward with implementing ISSI and CSSI, working with other infrastructure users and manufacturers to maybe start working on some basic features that we could then say, we'd like to see these features included if they're not already clarified or included in the standards. And the reason I mention that here is if anybody's interested in working on that in the user community, either in the EPIC or in other forums, Craig is a very active participant in the EPIC. We'd love to have people, if you got any ideas on that, we would be, your participation would be welcome. So I'm sorry I had to throw in a commercial there, but I thought this might be the good place to do it.
Craig's easy to find. If you're interested in getting involved with the FPIC, see me and we'll get you hooked up.
Got one more chart.
One more slide.
Yeah. Let's go to the last chart. There we go. Yeah, resources. So as Jim just talked, and then I use that example, and I'd say that example I gave you is, and you go back to what I said earlier, there's been a lot of press about P25 doesn't do this or that. And all the years I've been involved in it, that example I gave you of us clarifying in the standard on the emergency alarm operation over ISSI was probably one of the more significant changes made due to interaction with real systems coming in. There's been no major revisions of any of the specifications because of something that has been found in the last 15 years. There has been some work done to clarify some things because there's with any document, there is interpretation by technical people that's made, and sometimes the words have to be cleaned up so that we get everybody on the same page in interpreting stuff. But on this resources, via Craig here, and one of the things that didn't come out, Andy got cut off at the beginning, but Andy Davis has been involved in this many years. He's been the chair of TR8 for the last 2.5 years, but TR8 is what we call the plenary committee. It's the overarching committee over all the standards committees. So underneath TR8, and I didn't think to list it here, but what is listed are all the committees, but there's TR8-1, there used to be a TR8-6, there's a TR8-4. Each one of these things focuses on different aspects of P25, vocoders, the wireline, the trunking control and stuff. The one that's usually most applicable to the user side is there's this one committee called TR825, Compliance Assessment. That's a committee that was established for doing two things. It's a committee that creates what we call a Recommended Compliance Assessment Test, which is a document that the P25 CAP program leverages. So they go in and say, when we as manufacturers go and create all this 10,000 pages worth of documentation, what are the tests that you can actually independently run where you're not in a manufacturer's lab with the equipment broken down into its pieces? Well, the RCATs, the Recommended Compliance Assessment Tests, come out of this committee. And it's also a committee for any user to approach the TIA to say, we have an issue. And and then that committee, what can actually help go organize that, plus the P25 steering committee that Jim is the chair of and is also, I guess, the vice chair, whatever the user needs. That's a way to approach. So underneath this umbrella that we work in, it's kind of a three-legged stool. There's the TIA leg. There's what's called APIC. It's called the APCO Project 25 Interface Committee. It's actually a bridging committee. And no matter how I describe it, people who have been in this a long time will say I maybe didn't get it right, but regardless, it was created by MOU between TIA and NASTD and APCO. And that committee is a committee that's free to be a member of. In other words, you have to pay to be a member of TIA and vote. But everything we create that's a new direction for the standards starts in an APIC subcommittee. So for every TIA committee, like Jerry chairs TR819, which is wireline, there's an equivalent committee in APIC, or we'll create a new one. Users and manufacturers are equally represented there, and it's one agency, one vote. We do everything with conference calls. If you're interested and there's a particular subject you wish to pursue or push, then you can do it. And then within that committee is one that Jimmy's just resurrected, what we call the CAPTG, the Compliance Assessment Process and Procedures Task Group, is an APIC committee, and it's particularly there, so it helps feed TR825, but it's a place for direct user interaction into the process. So you have the ability to approach us through TR8, you have the ability to approach us through the steering committee, which is, by the way, the third leg of the stool. And then, as Jim said, the user needs is a subcommittee of the steering committee. And then you have APIC, which is a place where not only can the users input, but they can have a voting ability. And the only cost is the cost to attend or to spend some time on conference calls. Additionally, years ago, through work that Jimmy and Craig Jorgensen and Don Foll and a bunch of guys put together, we put this thing together called the PTIG, the Project 25 Technology Interest Group. It's a membership group. Users and manufacturers can join. It doesn't cost a whole lot. But at www.project25.org, there's a homepage. There's some documents that you can get to on that homepage. We've got a little bug on it. I checked on it the other day. When you go to the homepage, you can find a link to what's called the P25 Capabilities Guide. Several of us on the manufacturing side a couple of years ago worked together with the users, and we took things that are, and there's a thing I forgot to put on this chart called the Project 25 SOR, the Statement of Requirements. The user SOR is something created completely by the users, is maintained by the user needs subcommittee, and they publish this and update it on a regular basis. They try to do it annually, but that hadn't been that easy to do. But that drives the standards. In other words, the users say, this is what we want. User needs, gets together collectively, decides if there's consensus to do that, and then they push that to the standards. Now, the SOR is ahead of the standards. It takes a long time to create the technical documents, so there's things in the SOR that the standards may not address at this time. The more horsepower behind it from the user side, the faster it can be brought up. But anyway, www.project25.org. If you do .com, I don't know if it's still that way, but you'll find an entity that wants to sell you that domain for $10,000. But go to that and do that. Also, I didn't put on here, for those that are familiar with the National Telecommunications, National Public Safety Telecommunications Committee, NIPSTIC. NIPSTIC is where you can just put in NPSTI, whatever. You Google that, it'll take you to their site, and there's where that PAM tool is. And you can go, or you can Google PAM tool, P-A-M, and it'll take you to this spreadsheet tool that they created that will help you try to standardize your programming of P25 radios. And then there's work ongoing to actually try to standardize the interface from that tool to the radios through the various programming protocols that each manufacturer maintains, to see if we can further improve the programming consistency for users. I'm done.
Thanks, Roy.
By the way, Andy, do you have anything you want to add that we missed?
Nothing else for me.
Okay.
Well, I want to thank the panelists, and I want to thank you for coming. I'd like to know if anybody has any questions, because we've certainly given you an awful lot of information, so please come forward.
Yeah, if we can't answer it here, then we'll take it down and get back to you.
Hi, Stephen Rodriguez. This question's been alluded to, at least the answer has been a couple times. But you talked about the multiple languages for ISSI. What would happen if the home base system does an upgrade, but the other systems don't, that are connected with ISSI, or potentially?
Again, everything has to be coordinated. You know, if an entity is not part of the team, right, and does upgrades and you don't coordinate with the other entity, you know, now upgrades don't tend to destroy profiles that you've put into the system. I assume when you say an upgrade, I'm doing a version upgrade.
Correct.
To bring some additional capability. So, you know, unless something's just gone horribly wrong, everybody upgrades their system where you do a software load, you pick a maintenance window, you know, you dump this in and spend a certain amount of time possibly offline depending on how serious the upgrade is. All of your profiles and everything are untouched when you do that. But if that upgrade brings a new functionality, now maybe you're doing the upgrade because you want that functionality and that functionality already existed on the other side of the ISSI, then it's just an issue of then programming everything in, but obviously there's an impact to all the radios involved that you've got to, you know, you may have to go touch all the radios depending on what that does. And as you know, that takes a lot of time.
Sure.
I hope, did I answer your question?
Yes, yeah, that did bring more clarity to it.
Okay,
I appreciate
great.
that.
Thanks, Stephen.
I'm Curtis Piona with the Polk County Sheriff's Office. I have a couple questions. The pamphlet talked about local control and coverage, and one of the bullet points was seamless PSAP backup between agencies. And I'm worried now that the seamless backup between PSAPs was this, ISSI, and we're an FDMA shop, all of the radios we bought for all the entities that we work with. And so this looks like, I'm a little fearful that this is going to be a really heavy lift for us if we try and go this route, or even if we just put in an application to be, let's see, the lowest level user. If we bring 1,000 radios to you, we seem like we might be flying your ointment as far as your capacity. Am I reading all that right, Craig?
Well, if you bought, so that now he's getting into a very localized question.
Yeah.
So if you've purchased radios and used any of the money that came out of the 911 Council funds, those were to be P25 capable or P25 TDMA capable.
Okay.
If the other side to that is, I don't know where the PSIC money, grant money exactly went, but I believe there was an agreement to be in alignment with the statewide system when it came out. So with regard to the console interface, I'm not, I think I'd have to get more information from you to understand that. That's a good question, but I think I'd need to understand that better. On the radio side of things, if you bought all FDMA radios and they are not upgradable to TDMA, in other words, if you bought it, and I don't know who you would have bought them from or how long ago you would have bought them, but if the radios are not upgradable to TDMA, then that's something that we don't want the application, Curtis, not at all. We just need to understand what the ramifications of that are, and then the expectation would be that through the MOA, as you either have the capacity to upgrade or as you purchase new equipment, it would be TDMA capable.
Capable or enabled? I guess I'm
Enabled.
gonna draw the line.
Enabled.
So really, to really be able to be a user on the system, it needs to be TDMA enabled, not just capable.
Well, no, I'd love to say that. I'd love to say that's where we're going to start and end, but that's not how it's going to work.
Oh,
It'll have to be
okay.
an evolution. So
Okay.
the 6 talk paths, if you think about it, the 6 talk paths is a lot more space than we're going to need at a lot of places.
Okay, okay.
In some places, it may be the right amount of space.
Sure.
It's those places then where we have to look at how do we go back and solve that problem, because these FDMA users are showing up. So the system provides a report on a regular basis, like daily. How many busies, how many close you had, how many push to talks, how many. So we're talking about interoperability talk groups, as I understand the conversation right now. The interoperability talk groups coming through an ISSI or coming through directly on those radios. I assume you're talking about coming through directly
Initially,
on
I'm
those radios.
thinking directly, yes.
Okay, so coming through
I
directly
click
is on,
over,
right,
yep.
click over. That then has an impact of taking and two talk paths and bringing it down to 1.
Right.
So we have to know so in your application that we talked about in hour 2, we would ferret a lot of that out and say, okay, here's what the real threat to that is. Then we'd have to take it to the vendor and say, what's this going to do to create a service, et cetera. User group committee would have some more vetting questions. But my suspicion is that as you looked at future procurements, you then would be looking at TDMA enabled, capable and enabled radios that reduce the probability of degrading the system, or we find some way to partner and enhance the capacity of the system by adding additional channels. That's another option. There's more than one way to get there. This just happens to be the build out side of it right now.
Yep,
So a
yep.
really good question. I appreciate it. I'd like to talk to you offline though about that.
Sure.
The dispatch side.
Glad to.
Thank you.
Thank you.
Thank you. Anybody else? Well, then I'd like to ask each of the panelists to give us a parting words of wisdom. You've seen some of you've given us a lot of information. What is the single biggest challenge? Maybe I've scoped the question. What's the single biggest challenge in implementing an ISSI should we choose to do that? So Roy, I'll start with you.
I think I've touched on a lot of those elements through this, so I don't have really much to add to what I've already said. Again, it's as Craig said. My biggest focus or suggestion to you is you need to think about your use cases. And when you talk about a use case, I'll give you an example of one that I thought was interesting off of one of our systems. The city of Westminster, Colorado has an ISSI connection with the Colorado, what's called the Front Range system. It's got a funny acronym, FR or something. Most of the time we talk about ISSI in the context of like the DFW airport example, where it's just there for, mainly the only time it's used is there's a couple of times a year they do training, and the rest of the time this stuff is just latent in the back of everybody's mind. The training is to keep people and by the way, that's an important element of this, is that you can't just put an ISS out there and have these concepts of operations and all these agreements. It's going to require continuous training to keep everybody, particularly if it's something that's just used in a mutual aid thing. There's going to have to be planned and continuous training so that people know how to use it, understand the operational aspects of it, and how they're expected to operate on it, and that the people operating the system can recognize that if we're getting a capacity issue, then that may be a reason to do talk group combinations. In other words, you say, I can't, in order to manage this, we're going to take these two 15-person talk groups, we're going to merge them into a 30-person talk group. That way, they're limited on how much they can talk, and they've got to understand that if we make you a bigger talk group in order to help maintain the capacity of the system, when you do big talk groups, then there has to be some agreement on how, not everybody in that talk group is allowed to talk other than supervisory personnel unless there's an emergency. That's kind of an example. The Colorado Front Range thing, turns out they use their ISSI for prisoner transport. It's kind of an interesting case. They've got to move, there's prisoners that are picked up that are wanted from another jurisdiction, And so it's like, you know what, they wanted, because of some of the fears they have in moving some of these people, they wanted, the ISSI is used to keep certain users in both multiple systems informed that when there's any communication going on with prisoner transport, that the console operators in all the systems involved hear it, because they're moving, and they're moving across these lines and moving across several. Think of use cases, because you need those use cases so that, like in your case, there's you might be able to plan a different type of transition. I don't think there's anything there to be fearful of. It's more from the standpoint of, let's understand what we need to do. It may just be easier to have a certain number of radios that are multiband, that you can have certain users that are authorized to go work on the mutual aid channel on the other system, and as time goes on, you procure more radios, or your system grows, that you can start looking at capacity adds and whatever types of things you can do that. It's, as I think Craig put it very cleanly, which is, tell us what you need, and then for everybody, think of your use cases, document them, and then think about how your agencies that you're neighboring with, what do a lot of you probably have agreements with the most entities that you usually operate with that say, how do we behave when you're in part of the system? Sometimes people are carrying multiple radios to work with multiple systems. I know the ambulance guys do that a lot more than most everybody else, but think of leverage what's there today and use that to help you figure out how you build this bigger system.
Thanks, Ray. Jerry, anything to add?
I think I would say you can't just plug the ISSI in and expect it to work as you want it to work. You have to understand your use cases and what the capabilities of the two systems are to make sure that they can do what you expect them to do.
Okay, thanks, Jerry. Mr. Bob, do you have anything to
I'd
add?
just like to put a plug in for Craig's work on getting this group together, and feel free to let him know. My expectation is the only way that we're going to solve this and get through it is by these type of sessions where we can actually work together and see each other. So my hat's off to you guys for taking time out to come work through this, and I know we're going to have more meetings, but I also appreciate Craig putting it together, so thank you.
Thank you. Jimmy? Okay. Go ahead, Jim.
Yeah, I just basically I agree with what both Roy and Jerry said, and emphasize from a user aspect basically, and this is going to sound kind of like anti what we're talking about, but one of the things that we find from the users is make sure you understand what, again, it goes back to use cases. What do you want the ISSI to do, or what do you think the ISSI is going to do? And in some cases, quite frankly, as you look at it, depending on what your expectations are, the ISSI might not be the right solution. Don't go out and say, I got to go buy an ISSI when the reality of it is you might not. There's other ways of interoperating on a system in the statewide system that you might want to look at. And strictly from a user perspective, manage your expectations a little bit, and don't get led down a path. And I don't mean that anybody's trying to lead you down a path here, but just make sure that the ISSI is going to satisfy what your expectations are before you sink a lot of resources or a lot of capabilities into it. The other thing is, though, as along that line, one of the things we found from the user community is, along with that, and Craig has emphasized time and time again in both the first 2 hours about MOUs and MOAs and signing, doing an application and stuff. You can't imagine in the user community when we go to some of these working sessions and things, the simple thing up front of just having some kind of a service level agreement between the two entities that have the infrastructure of not doing that up front, and then all of a sudden this didn't work, that didn't work, and it comes back to one of the words we use constantly in the SAFECOM interoperability guideline is governance. Make sure you have that established in it. Looks like here in Iowa, you've already got that established through a number of different forums and venues, but don't sell that short. You've got to have that in place because it could save you a lot of heartburn down the road as you implement the ISSI.
And I would like to add to that, I'm going to ask Andy Davis to join us here, his final comments, and then we'll close out. But governance doesn't mean you can't. Governance means finding the best practice to achieve it. A lot of times people hear governance and they think, oh, that means you're going to tell me what I can't do, and that's not the intent at all. The intent is trying to find that best practice and then get on a path that enables what we want to happen over time. So, Jimmy, I appreciate you bringing that up. Andy Davis, can you hear us?
Yes, I can. Can you hear me?
Yes, sir. Please go.
All right. I just want to emphasize the importance of planning. Any system, especially a statewide system, especially when there's multiple manufacturers and various ages of equipment, planning is the most important thing you can do. It's easy to change a plan. It is not easy to change an implementation. So the P25 standards are what the user needs subcommittee thinks are important for public safety communication. But do not assume that just because they think it's important, it's everything you need. You really need to figure out what do you need, what kind of communication capabilities do you need? Radio to dispatcher, within a single coverage area, moving across coverage areas. You really got to understand what you want, then see if the standards enable it, then see if the manufacturers have built it. So planning is, I think, the most important thing you can do.
Thank you, Andy. And with that, I'd like to thank our guests. Could we give them a round of applause for putting themselves out to come and join us here? Thanks, everybody. Thanks for coming, and that will close out our summit 2 minutes early. Thank you.